We now talk about oscillations in a LC circuit. So LC circuit means we have an inductor and we have a capacitor. So you consider a capacitor and an inductor connected to each other as shown in the figure. So let us name this figure 1. You have a capacitor and an inductor. So the charge on the capacitor is Qm at time t equals to 0. So this figure 1 is at time t equals to 0. So as soon as the circuit is completed, so say there was a switch in the circuit and at time equals to 0, we completed this circuit. So you have this complete circuit exactly at time equals to 0. Capacitor is fully charged. Now the charge on the capacitor decreases. So the current always flows from positive to negative. So the current starts flowing like this. And once the current starts flowing, the charge on the capacitor decreases. So according to the Kirchhoff's loop rule, you have Q by C. This comes from the capacitor. This is the voltage across the capacitor. And this is the back EMF produced by the coil. So this is back EMF produced by the inductor. So this is also a voltage, back EMF, and this is also voltage which comes from the capacitor. So loop rule says that basically sum of voltages would be 0. So this minus L di by dt comes from the inductor, and Q by C, this is the voltage which comes from the capacitor. So this is equal to 0. So as the charge decreases on the capacitor, that is as the current flows, more and more current flows, the charge decreases and more current flows. So this current is equal to minus dq by dt. Notice the minus sign. That means as the charge on the capacitor decreases, more and more current flows. So obviously the current is flowing because of the charge. So as the current flows, it takes the charge with it, and therefore the charge on the capacitor decreases. But you see that I is equal to minus dq by dt, because as the charge decreases, current increases. Now we rearrange this equation here. So this equation we can rearrange, and we can rearrange this equation. So let us do this. So this equation you can write as di by dt is equal to Q by LC. So we have rearranged this equation. Now I we are saying is minus dq by dt. So instead of di by dt, we can write minus d2q by dt2, because instead of I we are writing minus dq by dt. So now again rearrange it. So you bring both of these on one side. So you get d2q by dt2 plus 1 by LCQ. So this is nothing but second derivative here. So this is the second derivative right here. So this is the second order differential equation we get. So this is the second order differential equation. So this equation you can solve, and this equation, I mean, you cannot correctly solve it because this is more of harmonic analysis, and it would require exponentials and complex analysis to solve this very quickly. Or you could use some other analytical techniques, but that will take a lot of time. But that is not important for us. We already know the solution to this equation. So for this equation, the solution is we solve for Q. So Q comes out to be Qm cos of omega naught t, where this omega naught is 1 over square root of LC. So this you have seen before as the resonant frequency. So what is I? So I is equal to minus dq by dt. So you differentiate this equation, and this will give you minus Qm, and then you have omega naught, but you also have minus sine of omega naught t. So this minus minus cancels out. So you get Qm omega naught sine of omega naught t. So notice that everything is just the differentiation of this. Qm is the maximum charge, which is a constant, which is given to us at the start. So this is what the current is. So now you can see the charge is cos of omega naught t. and I is sine of omega naught t. And you know that cosine and sine, they move in opposite directions. So when sine is maximum, when sine is 1, cosine is 0, and so on. So this means that there is oscillation between the charge and the current. So you have cosine here and you have sine here. So when time is 0, sine is 0, but cosine is 1, and so on. So let us now see the oscillations more figuratively. So what essentially is the process? So from analytically it is clear that there is oscillation. Charge moves as cosine and current moves at sine. But let us now see a more descriptive form. Now as the switch is closed, the capacitor starts discharging. So you can see in figure 1, the current starts flowing out of the capacitor. So as current increases, it sets up a magnetic field in the inductor. So as the current is flowing through this inductor, it is setting up a magnetic field there. So there is some kind of a magnetic field being set up here. So when the current reaches its maximum, so when the current is maximum, the capacitor gets fully discharged. So when the current is maximum, all the energy is stored in the magnetic field of the inductor. So notice that the capacitor is fully discharged. Capacitor is fully discharged. So we are now in figure 2. So the capacitor is fully discharged and all the energy now is stored in the magnetic field here of the inductor. So in the magnetic field, you store all the energy. So again, you start with a charged capacitor, current starts flowing out of it, current reaches the inductor. Now since the current is varying, it induces a magnetic field in the conductor. Now this magnetic field keeps increasing because the current is also changing. So when current reaches its maximum, you have all the magnetic field inside the inductor. Now this magnetic field was producing back EMF, so it is not letting the current pass through it. So it is just storing the current as magnetic field. Again, this inductor is producing back EMF, so it is not letting the current pass through it. It is storing the entire current as the magnetic field. Now the capacitor is fully discharged, so there is no more current flowing through it. So the magnetic field now induces current. And this current now flows like this. So this is figure number 3. So now the current starts flowing out of the inductor because of the magnetic field, and this again charges the capacitor, but the polarity of the plates is reversed. So the polarity of the plates is reversed. So now the current starts flowing out of the inductor and you get positive charge right here. So notice the positive charge is right here. So earlier the positive charge was right here. Now the positive charge is right here. So now again the current will start flowing in this direction. So the current will start flowing in this direction. This will again induce a magnetic field. This magnetic field will again induce the current, and which will charge the capacitor like this, and the cycle will continue. So the cycle is from figure 1, you go to figure 2, from figure 2 you go to figure 3, from figure 3 you go to figure 4, from figure 4 you go again to figure 1, then again figure 2, and so on. So this is what the oscillation is. So the charge keeps reversing and you can see the direction of the magnetic field keeps reversing. So notice the charge has reversed and the direction of the magnetic field has also reversed. So these are called LC oscillations.